Okay, so number 14 here. So first, let's draw a picture. The train is traveling northwest 60 miles an hour, and let's see. I'm going to make an axis like that. Okay, so northwest 60 miles an hour is going to be, well, I don't know, something like that. Yeah. Okay. All right. Now the BB gun, he's aiming at 30 degrees south of east. So the BB gun, 30 degrees south of east, and he fires, and the muzzle speed is 100 miles per hour. All right, so 30 degrees south of east, there's east, right? 30 degrees south of east is like that. So that's 30 degrees. And let's see here, then 100 miles an hour means, I'm just going to try to draw this roughly to scale, maybe something like that. Cool? Everybody happy? Okay. Now, so the hint is critical here. The hint says that, let me write this in black, that the muzzle velocity of the BB is measured relative to the gun. So, I mean, we're on a train. I mean, if you're on a train and it's cruising along, you might get up and take a leisurely stroll at 2 miles an hour. But if the train's doing 60, then you're actually doing, well, 60 plus whatever your stroll is, And so there's the same kind of thing going on here. The gun is on the train. Now, the gun is fixed relative to the train, but then the BB is moving relative to the gun. And, of course, the gun is attached to the train, which is also moving. All right. So the big hint is given right here, that the velocity of the BB, and I don't remember if I've used a different, I guess I don't have notation set here, so I'll just say the velocity of the BB here. Excuse me, the muzzle velocity. So the muzzle velocity is the difference. Okay, so is the difference between the velocity of the BB and the velocity of the gun, but of course the gun is attached to the train. Alright, so now let me color code this. The velocity of the train, we already agreed, is that red vector there. The velocity of the muzzle velocity is that thing right there. That's in blue. And we're being asked to find the velocity of the BB. Well, we're actually asked, how fast is the BB going when it hits the tree? So we're going to compute the velocity, but technically all we really need to know is the speed, right? But it turns out to be much easier to compute the velocity because you can see it right there in the equation, right? Okay. So not surprisingly, what we're going to do is just subtract, and we get that the velocity of the BB. I don't know why I said subtract. I mean, we're going to take that red and bring it over to the other side of the equation. Velocity of the BB is the muzzle velocity plus the velocity of the train. So you might think of it this way. There's two things that are making the BB do what it's doing. The BB started off moving along with the train, right? Before he pulls the trigger, the BB is already moving with the train. And then in addition to that, it's also picking up whatever velocity the muzzle gives it. So that's just an intuition for where that comes from. Okay, so now this is, I guess, where your question starts. Yeah. Okay, so let's write down what these things are. The muzzle velocity. Well, I want to look at this blue vector here. That's 30 degrees. And I know that magnitude is 100. And so I need to now write down the two components of this blue vector. Well, the first component is 100 cosine of 30 degrees. All right, that tells you that that's sort of the x part. There's a little bit of trig there. Is everybody happy? Right? And then the second part, well, it's negative because it's clearly going down. So negative 100 sine of 30 degrees. Yeah? Or if you prefer, I could say 100 cosine of negative 30 because the angle is down. Maybe that angle is negative 30. And then 100 sine of negative 30. And this minus sign here comes out because sine is an odd function, and the other one doesn't because cosine is an even function. Yeah. Everybody good? Okay. All right. So let me just go ahead and pull that minus sign out there. Okay. All right. Now plus a similar deal. I'm just looking at the velocity of the train now. This is the red vector, that vector there, and you can think of this in different ways. I mean, you can think of that angle as being 135, right? 3 pi over 4. Or if you'd like to, you can just think of this angle as being 45, and then use your geometric intuition with the pluses and minuses like I did earlier. So let's do that. And so let's see here. I would get the magnitude was 60. So here I'm going to have 60. Negative 60 sine of 45 degrees and positive 60 cosine of 45 degrees. And I'm doing sine and cosine because I chose that angle. If I had instead used this angle as 45, then it'd be cosine and sine. Conveniently, they're the same number, so it doesn't matter, right? But anyway, I'm just trying to be consistent. And so at this point, we're done with what we can do without a calculator.
If you had done it the other way, would that have thrown off the final answer?
No, it'd be same answer.
Okay.
Yeah, same either way. Yeah.
But if it was different angles, I mean. Because like you're saying,
oh well, if the angles are different, then yeah, I'm just saying.
45. So.
If you think of this x component as being related to the sine of that angle, or if you think of it as being related to the cosine of that angle, it's the same either way because sine of 45 is the same as cosine of 45. If it had been different angles, then it'd be the sine of one angle and the cosine of a different angle, and they would be different. And either way, it's the same answer. Yeah. You had a question?
Yeah, I was going to ask where you got the 45 degrees from.
Well, that was given in the statement of the question. It's traveling northwest. So you're supposed to interpret it that it's straight exact northwest. Yeah, and in any situation like this where, if we don't interpret northwest to mean exactly northwest, then we don't have enough information to answer the question. And so the only plausible interpretation of the intent of the question is that it's supposed to be exact. Yeah. Yep.
Can you just roll down?
Oh, yeah. Right. Yeah, sure. Yeah, no worries.
Wait, why is it negative 60 times sine 45 again?
Yeah, so
it's in the positive direction?
Well, no, the x, if you're looking at this red vector here, right, the first component is the x part of it, and that's negative. Yeah.
Thank you.
Yep, sure. Okay, so the last thing to do here is you have to actually crank this out. Let me use a different color here. I'll use black. You have to actually crank this out and get an actual number for the x component and an actual second number for the second component, and then the speed that we're looking for is the magnitude. Yeah, it's the square root of the sum of the squares of these two numbers. And you got to do that numerically because there's no algebraically convenient way of doing that. Yeah. Everybody happy?
Quick question.
Yeah.
In a sense, if we take the vector of the train in the northwest direction and the vector of the BB gun in the 30 degrees southeast,
yeah.
If we put them next to each other, we're going to be getting the actual vector of the speed of the bullet.
That's the idea. That's the idea.
Yep. The magnitude of that vector.
So you can sort of draw if you were to draw this summation, what that would look like is, you'd have this red vector, and then plus the train vector, and I hope, this isn't to scale, but that's my best shot, right?
Yeah.
But so the resulting sum then, this thing here would be, whatever that, and I can't remember if, right.
Definitely difficult to do it by scale. But
Yeah, exactly.
Do you have any way to get that directly, though?
Not algebraically, just use calculator.
No.
Yeah, so just,
Yep.
Okay, everybody happy? Yeah, no problem. Okay, all right, see y'all later. Let me stop this recording.